All right, guys, so this is the video for section 8.4. And in this section, we're going to talk about finding sums for an infinite geometric series. So when I talk about an infinite geometric series, I talk about, it keeps going to infinity. Okay, that's what infinite means. Now, notice this only works for an infinite and for a geometric series, okay? So here's our formula that we'll use. Now this formula is pretty simple. The catch here is that our absolute value of r has to be less than 1. So think of what our r is, okay? So our r is our common ratio. Okay, now if our common ratio is greater than 1, or if the absolute value is bigger than 1, our numbers are going to get bigger and bigger and bigger and bigger, and they're going to go all the way to infinity and beyond. Okay, so we can't find the sum when our numbers get bigger and bigger and bigger. Now what happens is if our common ratio is less than 1, or if the absolute value is less than 1, then our number gets smaller and smaller and smaller and smaller and smaller, and it comes very, 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 very close to getting to 0, not infinity. And so we can calculate the sum because eventually we get numbers so small that when we add them, it's essentially 0. Okay, so that's why our R value has to be, the absolute value of our R value has to be less than 1 to use this. If it's greater than 1, we would just write we cannot calculate the sum. All right, so let's look at example 1. Now I'm just going to write this equation out right here. So my sum's going to equal the first term over 1 minus R. Okay, so the first thing I need to look for is my R value. I'm going to put here the absolute value of R must be less than 1. Okay, here our absolute value of R is less than 1. So basically, if you think of this in terms of a geometric series, we're multiplying each number times 0.7. So we're getting smaller and smaller and smaller and smaller and smaller. Okay, so because we're getting smaller, we can calculate the sum because it's not going all the way to 0, because this is essentially going to become an extremely, extremely, extremely small number. Not ever 0, but an extremely small number. Okay, so to find the sum here, I would just take our first term. Now notice this is in geometric form, so here's our A1. So our first term is 3 over 1 minus our R, and our R is 0.7. Okay, which is essentially 3 divided by 0.3. And if you put that in your calculator, our sum is going to be 10. Okay, it's that easy. All right, let's look here. Okay, let's first make sure this is geometric. So 1 to 3, we're multiplying by 3. 3 to 9, we're multiplying by 3. 9 to 27, we're multiplying by 3. So our R value is 3. Okay, here is an example. Okay, if I were to write this as geometric series, okay, I would write it as A1. Ooh, A1 is just 1, sorry. Times 3 to the n minus 1. And I want this from n equals 1 to infinity. That's basically what I'm doing, is finding the sum. Now here, guys, my R value is bigger than 1. Okay, so that means these numbers are going to get bigger and bigger and bigger and bigger and bigger. And if the numbers continue to get bigger, our sum's going to continue to get bigger and bigger and bigger and bigger. So what I would write here is just say the sum does not exist. Okay. All right, I want you to go ahead and try C on your own, and then we'll go over it. All right, so this is what you should have gotten for part C. All right, if you didn't get part C correctly, go ahead and try these two, or even if you did and you're still not real comfortable with them, go ahead and try these two, and then we'll go over them. And here's what we should have gotten for the monitoring progress if you completed them. All right, so let's go ahead and look at this. It says, a pendulum that is released to swing freely travels 18 inches on the first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. Okay, so our R is, okay, 0.8. What is the total distance the pendulum swings? Okay, now it tells us that the first swing it travels 18 inches. Okay, so this is our A1. Okay, so to kind of just set a rule if I wanted to, it'd be A1 times 0.8 to the n minus 1. That would be our rule. Okay, now we want to find the distance on each side. We want to find the total distance the pendulum swings. Okay, so we want to find this distance plus this distance plus this distance plus this distance all the way to infinity. Okay, so because of that, we could use the sum of an infinite geometric series. So we could use the sum equals A1 over 1 minus r. And notice our r is 0.8, which is less than 1. So we can totally do this. Okay, so if I wanted to do this, I would write our A1, which is 18, over 1 minus r, and our r is 0.8. So this is just 18 over 0.2. And if you put that into your calculator, you would get that it travels 90 inches. All right, so let's look at example 3. Now, example 3, these are really fun to me. I don't know, call me a nerd. But these are really intriguing. Okay, we want to write this as a fraction in simplest form. Now, to do this, we are going to write it as a sum of an infinite geometric series, because that's what these points go. It says 2, 4, 2, 4, 2, 4, 2, 4, on and on and on. Okay, we've all seen numbers like this. Okay, so correct me if I'm wrong. Could I write 0.242424 dot dot dot, keeps going and going and going, as 0.24 plus 0.0024 plus 0.000024 plus dot dot dot. Okay, you should be able to recognize that the left and the right are in fact equal. Keep in mind what an equal sign means. They're the same. Written differently, but they are the same. Okay, now if I notice to get from 0.24 to 0.0024, 0.24x equals 0.0024. I divide both sides by 0.24. I would get x equals 0.01. Ooh. X equals 0.01. So this is times 0.01. Okay, to go from here to here, if you don't believe me, this is times 0.01. Okay, I could keep going and going and going, and I would notice that we're always multiplying by 0.01, and therefore this is a geometric series, okay? I can write 0.242424 repeating as a geometric sum over here, okay? So now that I have that, I can write this side, and remember, this is equal to this side. Remember what equal means. They're the same as the sum, because I'm adding all these, of a geometric series. Okay, so the sum is going to equal my A1, which is 0.24, over 1 minus my R, which is 0.01. Okay, this is just 0.24 over 0.99. Now, remember when you have a fraction with a decimal, I can multiply both sides by 100. And all that does is change this to 24 over 99. And then that simplifies. 24 over 99 goes, each of those go into 3. So 8 over 33. That's my sum. So I can write the right side as 8 over 33, which means that I can write the left side as 8 over 33 as well. So if you look into your calculator, if you do 8 divided by 33 and get a decimal, you should get this. All right, so using this as an example, guys, I want you to go ahead and try B on your own. Now, I'll give you a hint. We're going to write this as 777 dot dot dot. That can be written as 0.7 plus 0.07 plus 0.007 plus 0.0007 plus dot dot dot. Okay, so go ahead, find your R. Okay, it's going to be the same throughout, and then put it into the sum. All right, when you worked this one all out, you should have gotten that 0.777 repeating is really just equal to 7/9. Okay, now, If you had a problem with those, go ahead and try one or both of these. Go ahead and pause this, try these both. I'll work them out, and then I'll show you the answers. All right, so this is what you should have gotten on the top one. You should have gotten 5/9. Here's your work. And then if we scroll down, you should have gotten 13/99 here, and that doesn't reduce, so it's just 13/99.